This is 7-6 Math, Lesson 117, Mass and Weight. So before we get into the book information, I wanted to describe to you the difference between mass and weight. And it really only applies to scientists because for the most part, day-to-day living, they're used interchangeably. So for mass, it's the amount of matter in an object. It is constant, and it doesn't change with a place. The unit of measure is the kilogram, and the way that you measure mass is with a balance. So it has this, maybe like a triple beam balanced or like that. So we have them held like this, but on one side you have what you're trying to measure, and on the other side you have standards. So the Bureau of Standards will release, or you can buy them, little measures here. So pretend like these each weigh 5 grams. We know that they're 5 grams because they've been prepared against a standard. So when it balances out, we know that whatever's on this side is exactly 10 grams. And it would be this way on the moon, and it would be this way on the sun. It doesn't matter. This won't change. Weight, on the other hand, is the measure of the force exerted by gravity. It can change from place to place. On the moon, you weigh less than you do on Earth. On the sun, you weigh more than you do on Earth because the gravitational pull of the moon is not as strong, so you don't weigh as much. That's why astronauts seem like they bounce. And on some place much more massive than Earth, like the sun, if you could stand on it, you would weigh a lot more, but your mass would be the same. So then this varies from place to place, depending on the nearest, most massive object. And we measure this in newtons. And the way that you measure it is you have, maybe you've seen these at the grocery store. There's a spring here, and then maybe you put some apples on there, and it pulls the spring down, and then the spring will be measured with some sort of zero clock looking thing that points to whatever pounds or newtons that you're using. But really they're used interchangeably, and for U.S. customary, we use pounds, and for metric, we use grams or kilograms. Mostly you don't use newtons unless you're talking about some scientific endeavor. Okay. So they're giving you some things that they're telling you the mass of. So they say a grain of salt, this one little piece of salt, is about 1 milligram. A paper clip is about 1 gram. And a math book is 1 kilogram, depending. So we're learning the conversion between different units of measure. We need to know that 1,000 milligrams equals 1 gram, and there are 1,000 grams in 1 kilogram. We also need to know the U.S. customary measurements. There are 16 ounces in 1 pound and 2,000 pounds in 1 ton. In the example that they first give you, they ask you 2 kilograms is how many grams? So 2 kilograms. Okay. We are converting kilograms to grams, so we need to know this unit conversion. If 1 kilogram is 1,000 grams, then 2 kilograms is double that, or 2,000 grams. And in example 2, we're subtracting mixed measures, 9 pounds, 10 ounces, minus 7 pounds, 12 ounces. we can't do the subtraction here. So we're going to borrow over. And the biggest mistake here is people assume that there are 10 ounces in a pound. There are not. There are 16 ounces in a pound. So I'm going to borrow a pound over here. So it's going to be 8. And I'll move the 16 ounces over here. So now I have 26 ounces. Then I can subtract 14 ounces. 8 minus 7 is 1 pound. So the difference is 1 pound, 14 ounces.